Okay, guys, I think that will be important to consider this part of our integration by parts using the DI method. If you take a closer look into the questions now that we are being given, sometimes you'll see that it is actually a tiresome to work out those integrals using the normal integration by parts that we are used to. As we do understand, we are supposed to work with our integration by parts having our f of x, then we've got g prime x dx, which is equal to f of x by gx minus the integral. This time we're going to have f prime x, then this will be gx dx like this. We had conditions. I actually talked about this, or we had this part with you guys working with introduction for N5 and N6. If you saw, we had questions that we ended up having maybe even repetitions in those integrals. We had questions, I want you to consider if you were working with an algebraic, maybe this is x to the exponent of 3, then we are given cos of x dx like this. You had a condition where when working with this exponent of 3, you are going to apply the integration by parts 3 times. If you are given an exponent of 2, you are going to apply this 2 times. And also there were certain integrals that we saw previously that we have to integrate again until we obtain something of that nature that we are given, e to the exponent of x, the sine of x dx. You integrate again until you obtain this, if you still remember. So on those integrals, we can avoid that confusion by using the DI method. So what is it that we are referring to this method, the DI method? So do not worry about this. This is simply the part that you can differentiate, the part that you are able to differentiate, the part that you are able to integrate. So hence DI method. So let's consider our method. Let's say we are given, in this case, I'm going to start with something of an algebraic and a trigonometric. Let's say we are given x squared, the sine of x with respect to x. So this is what you're going to consider. Like our method is clearly stating the I method. We have got the part of derivative and the part of the integral, like I said before. So this is what you're going to do. You're going to just have a small table that you're going to have part of the derivative, and you separate the part of the integral. You're also going to need the signs that are going to affect this part. So let's just have the sign, just like this. So this is the table that you're going to need. So the sign is just going to be like this, plus, minus, and so on, guys. Do not worry about this, plus, minus, and so on. So I'm going to explain about that. So this is it. On this part that you are given, which part that is easier for us to differentiate, which part is easier for us to integrate? So there we are given algebraic and trigonometric. And I said previously that it is easier that you work with an algebraic as the part that you can differentiate. Remember, when you're choosing f of x is equal to x squared, then g prime x is equal to the sine of x dx. The part that you can differentiate. So this is the one that you're going to write here. That is x squared. The part that you can integrate, which is the sine of x. So this is what you're going to do. So this is the part to be differentiated, the part to be integrated. So you're going to integrate, you're going to differentiate this side until you obtain a 0. That is when working with an algebraic expression. Algebraic term, actually, let's just say we are working with an algebraic term. Remember, algebraic terms, let's say we've got x to the exponent of 5. Guys, you can differentiate until you obtain what? Until you obtain a 0. So when working with an algebraic term, you must differentiate until you obtain 0, until you obtain a 0. All right, so let's try that. So we're going to differentiate the derivative of this one, that is 2x. This one you'll be integrating, okay? So integrate. If you do not want to have a confusion, you're going to finish this derivative. But because of some other integrals that you're going to have, you have to consider both at the same time. So I want you to be used to that. As you differentiate this column, know that you are integrating. So you integrate the sign of x. Remember, from our derivatives, when we differentiated the cos of x, we got sin x. So the integral, which is the reverse of this, is going to be a cos. So that's the cos of x. All right? Integrate. It was a negative, there was a negative here. Sorry for that, guys. Remember, that was a negative sign of x. So meaning to say here, we're going to have a negative cos. That will be a negative cos here. Remember, the derivative of a cos is negative sign. There I was considering as the integral of a cos. This is the derivative of a cos. So the reverse now, so it's going to be negative. Remember, there's a negative here, so this one will carry a negative. The derivative part, as I said, until you obtain a 0, because that's an algebraic term. So the derivative, again, of this 2x, I'm going to talk about the signs. Do not worry about that. So the derivative of this 2x, what is the derivative of 2x? That is going to be a 2. Remember, if you're given ax, just going to take your x there, your a. We integrate our negative cos. We know that the integral of this cos, integral of the cos, is a sine. But we are going to obtain this negative also affecting our answer. Remember, the derivative with respect to x of a sine x is the one that gave us what? A cos. So if you integrate a cos, you obtain a sine. But here there is a negative that is already there. Your answer is going to carry a negative. So like I said, when given an algebraic, you must do this until you obtain what? A 0. So let's do this. The derivative of this, remember our column, that's a 0. Okay, let's just integrate our sign. The integral of a sign in this case, that is the last part that you're going to do, because we now have a 0 there. So remember, guys, we had this part here of a sign. We integrated a sign on the first part here. We got a negative cos. But here there's a negative already, so it's going to be negative cos x. So that will be positive cos x. All right, so this is it. You were integrating on this column. The other column, you were differentiating this part until you obtain a 0, because we've got an algebraic term. Then the signs, like I said, there will be plus, minus, and so on. So here we are going to have corresponding here. Let's just do it like this so that we see properly. So you're going to have it like this. So this will be a plus, a minus, a plus, a minus. So you just have that sign, just like a continuation, plus, minus, plus, minus, plus, minus, plus, minus, and depending with what you have on your terms. So this is it, guys. You have your derivatives, you have your integrals. It's very easy. Do not worry, guys. It's very easy. You see that the previous method, that the previous part that we're using is difficult. Than it's not difficult, like it's lengthy than this one. This one is just direct. I want you to see here. So this is what you're going to do. You are going to multiply these as long you have a part like this one, as long you take it in this way, as long you take it across like this, as long you take it across like this, it means this part has been integrated already. But you must also consider what? The sign. So this is it, guys. We are going to say integral of x squared, the sign of x with respect to x is equal to. So here we are going to multiply along the column. along, across this, like this one, across. This is not along, but across this. Are you seeing that one? But considering the sign, so that's a plus, a minus. That will be minus x squared cos x. So that's minus x squared cos x. So as long you take it across like this, it has been integrated already. I'm going to explain later on about the row, about taking it as a row like this one. This one is to be integrated. But across like this, it has been integrated. So you're not going to put any integral sign. So we move on. This concept, guys, is going to be and so on. So here it's going to be like this. So let's just have it this way so that we do not have confusion. So you're going to have this one versus the negative sign of x, but the sign also considered. So it's negative times negative, which is a positive. Then we have got 2x times sine x. So it's going to be 2x, the sine of x. Okay, we move on to another one. So in this case, we've got this part again. We still can take across the 2 and the cos, but considering the sign. So the sign is affecting also. So that's plus and the plus, that will be a plus. So 2 times cos, we're going to have 2 cos x. So you're multiplying 2 times cos, which is cos x. So as we can see, here we are going to take 0 times what? Anything that we're going to have here times 0, it's what? It's a 0. So there's nothing there. So that is the idea. Okay. So this 0, well, even if you're going to integrate this, but the moment that you multiply by a 0 in this case, there is nothing that you're going to have. So meaning to say, we are done. So that is the constant plus the constant of integration. So as you can see, guys, it's a smart method that you can easily integrate. You do not have those rays of integrating again and integrating again and integrating again. No. We're supposed to integrate 2 times. Remember the x squared concept. I'm going to have a class where we have to separate this. Let's just stop, guys. The issue of time, okay? We have a class that we need to separate these 2 methods on a single video so that we at least we can understand. If you remember, we had this question in our introductions where we worked by parts. So we saw that when working with an algebraic term, you are going to actually stop when you have what? A 0 on your derivative. Okay, let's see this one. We had a condition or a question like this before from our introduction again. X to the exponent of 4, the ln of x with respect to x. We're asked to integrate this. So which part is easier for us to differentiate? Yes, we can differentiate this, which is fine. But let's go to the integral. Can we integrate the ln? It's difficult. Remember, actually, there's a question where you're asked to integrate the ln of x, and you're supposed to use by parts. So imagine you can take this to be your integral part. So it's easier for us to choose this to be our derivative, and this remaining part be the part of the integral, because for us to integrate a ln, guys, it's a by part method that is to be applied there. So you have to avoid that. You have to avoid that. So remember, so you're going to have our sign, the derivative, and the integral, that is di. Okay, so that is it. So let's consider in this case. So like I said, we are going to have this as our derivative because it's difficult for us to actually integrate that. So we are going to take the ln of x as our derivative, then x to the power 4 as our integral, just like that. So if you do understand the signs, guys, you know that here we're going to have what? A plus. Consider minus and so on and so on. Okay. So we said in this case, we are going to find the derivative. Let's differentiate. We can differentiate a ln, remember, guys, from our ln, that is 1 over x. Okay. We can integrate x to the exponent of a 4. Remember the integral of this with respect to x, we're just going to add 1 there, x to the exponent of 5 over 5. So this will be x to the exponent of 5 over 5 like this. We have integrated this. Now we go to the sign that is a plus. This one will be a minus. Okay, let's integrate. Let's differentiate. I mean, this is the column of the derivative. 1 over x, is it possible for us to differentiate this? No, that's impossible. Remember, x to the exponent of -1. When you are working with a derivative, I mean, you are going to have this continuous. It's going to repeat and so on and so on and so on. If you have this, you have got a -1, x to the exponent of -2 in that case. Then you drop the exponent, which was a -1, like this. But as you can see, guys, -1 over x squared. This part is going to have x to the exponent of 6. Then you divide, that will be something like 36 times this, that will be a 30. So I want you to see what's going to happen there. This is going to continue. This also is going to continue. We are going to have that continuously. We're going to be differentiating and so on and so on and so on. So now to avoid this, what we can do is to stop at this part. But as we can see, this is not going to give us a 0. Guys, the first part, if you consider this 2x, differentiate this, that's a 2. You differentiate a 2, that's a 0. You're having x to the exponent of 3, you differentiate this, that will be 3x, and so on and so on, is reducing until you obtain a 0. But in terms of a 1 over x, we are not going to obtain such. This will be increasing, guys. I mean, this will be like repeating. We're not going to have a 0. So in this case, you're going to stop. Also consider along this row that you're given, along this column that you're given, the row that you have here. Along the row that we have, can we integrate thereafter? It's possible for us to integrate. Remember, I was considering taking this across, which is actually the one that you're supposed to consider. But at the end, you must consider, if you're not having a 0, to say along this row, can it be integrated, which is the last one? It's possible for us to do that. On another condition, you are going to have this part here along the row being the same as what is here, which is not on this type of equation. I'm going to explain a different equation that you see being equal. So in this type of equation, where exactly do you stop? You stop at a continuum where you see that the derivative is repeating. The derivative is repeating, and we cannot have this part in the original sense. Remember, no matter how we are going to integrate here, we cannot have this ln. No matter how we are going to differentiate here, we are not going to have a ln. No matter how we are going to do, we are not going to have a ln. On another case, you stop when you can have the same part. So in this case, we cannot have the same question, exactly what you have on this question. You are not going to have that. So that's when you stop. When this is going to be a repetition throughout. But take note, this is not equal to 0. Yes, we stopped here, but take note. Take note. In this case, this is not a 0. 1 over x is not equal to 0. So meaning to say, we are going to integrate the last row. So in this case, if this last part here that you're having is not equal to 0, remember last time we stopped when we obtained a 0. But if you stop at a point where you are not having a 0, you integrate the last row in that case. So you are supposed to integrate the last row. I'm going to show you how do you integrate that. All right, so this is it. Remember the last part I was explaining about the multiplication across like this. It is not going to change. These two, we are going to multiply them together, considering the sign that we are given there. So it means the integral of our question, x to the exponent of 4, ln of x dx is equal to the product of these two. So a plus and a plus and a plus, yes, just going to be a plus. So that is be x to the exponent of 5 over 5, the ln of x along like this across this two. If as long you take a product across, it is already integrated. But look now, we are going to have a condition where we were supposed to have this, but it was going to be a repetition along. It was going to be, there was going to be a term here, but it was going to be a repetition that you're supposed to repeat and so on and so on. So to avoid that repetition, you are going to take that part where you stopped. Remember, this is where you stopped. You take that along the row. But like I said, you must integrate that. So this is what you're going to do at the end. Remember, this is not the way that you're supposed to take your answers. You're supposed to take your answers in another way, but look the way that you have taken your answers. As long you take that, you integrate that part. So this is going to be minus the integral of, remember there's a minus there, minus and plus, that's a minus. So it's minus the integral of 1 over x times x to the exponent of 5 over 5. The integral you are taking along the row, you multiply them along, but integrating. As long you take across, as long you take along like this, you must integrate. So we are going to integrate this with respect to x. So that is how you end up with an integral of this nature. So meaning to say, we are going to apply the integral on this end. But do not worry about this integral, guys. This is simply 1 over x times x to the exponent of 5 over 5. So this into this, that is x to the exponent of a 4. So meaning to say, we are going to take out the x to the exponent of a 4. So that is minus, okay, sorry, we're going to take out this 1 over 5 out of the integral. We remain with what? X to the exponent of 4 with respect to x. So this can be integrated. We can integrate this x to the exponent of 5 over 5, the ln of x minus 1 over 5 into, integrate that to be, remember you add a 1 when integrating, so that's a 5 over a 5 plus the constant of integration, because you'll be done. That's the last stage. So it is just a little bit of an integral thereafter, but this is not as much as it was on the original question, guys, as it was supposed to be, guys. So that is it. Remember, this is x to the exponent of 4. So you must be careful. We are done. We have got our constant of integration, like we integrated that part. So you must consider that when you are given a part where it's going to be a repetition in terms of the given term that you have. It's not like what we had of the algebraic. This is a reciprocal. So a reciprocal is going to be a repetition. X to the exponent of 3, when you are differentiating, it will end up having a 0. But these exponents of a negative, once you have a negative 1, it is not going to end. It is not, once you have this, you stop. It is not going to end. All right. But let's consider another part where we are going to stop whilst we are working with our integrals, working with our DI method. Do not confuse these two. I'm gonna just try to have another question so that we do not confuse where we are going to stop. Remember, we had also from our by parts something like this: e to the exponent of x, the cos of x with respect to x. Okay, and I said on exponential and trigonometric, there you can choose any to be a derivative and any to be an integral. Remember that. So in this case, we are going to have any part. So it's up to you. You're going to choose the D to be the E, or you're going to choose the other part, that part of an exponential and a trigonometric, any part. All right. So I'm just going to take as it is from our question. Part of D, I'm going to use e to the exponent of x, then the integral, the cos of x. Then remember the sign, we're going to start with a plus, and so on and so on. All right, let's differentiate. If you differentiate e, that's e to the exponent of x, okay? If you integrate a cos, remember this part you're integrating, we integrate a cos from our sine. Sine gave us a cos, so meaning to say cos is just going to give us what? A sine on the integral. Okay, so the question is, last time you were saying, if this is repeating, then you stop. Okay, I said that, which is true. I said you must stop. But in this case, all right, there's a plus, there's a minus here. But in this case, you are not going to stop because this is repeating, like e to the x. There's no, you're going to have this e to the exponent of x and so on and so on. And we're not going to have a 0. In algebraic, you stop when you see a 0. And normal algebraic, like not the reciprocal. A reciprocal, you just stop when you say that reciprocal, this is a repetition. But in this type of a question, I want you to see it is different from the last part, because the last part that we had, remember we had x to the exponent of 4, the ln of x dx. On whatever stage that we had, remember when we had the ln of x, it ended up having 1 over x, and the other part, it was x to the exponent of 5 over 5. We stopped at this stage because no matter the way that we are going to integrate, remember that I was explaining that we cannot have this term as it was before. We are not going to have x to the exponent of 4 and ln x, no matter how we are going to differentiate and integrate. So you have to stop at that condition where the repetition is. But in this case, if you look closely, the e to the exponent of x is going to repeat as it is. What about a sine? A sine, there's no way it's going to go back to the cos. So mean you say in this case, you have to stop when you see this repeating, wherever you see e to the exponent of x cos x. Once you see this repeats, you stop. You stop there. So let's see. E to the exponent of x, we differentiate. It's e to the exponent of x. You integrate this side, okay? Sine, remember the integral of a sine, that's a negative cos. Cos gave us a negative sign, so that will be negative cos. And this is plus, minus, plus. Okay, let's take a closer look along this row. This is what we have in this row. E to the exponent of x, e to the exponent of x. Cos of x, cos of x. We have exactly what we had from our original question. Do not worry about the sign. What about the terms e and cos? This is what we have. So this is what I was saying from the previous case that it was going to be impossible for us to obtain that x to the exponent of 4 ln x. It was going to be impossible for us to have this term, no matter how we were going to continue differentiating. So that's why we had to stop at that initial condition. So you have to just take a closer look also along. So once this part here repeats, this part, it repeats the original question. That is our original question. You have to stop at this case. We are not going to continue anything. We stop at that part. But look also closely. We stopped, yes. But where we stopped, is it a 0? No. So I said once you stop at a condition where this term is not as whatever that you have, remember the previous case, it was not a 0. So what is going to happen if it is not a 0? You must integrate the last part. This one is not going to change. You integrate the last, or that is the last row in that case. So we talked about this, how we are going to integrate this. We take this as a row, this row here, just like the previous case. You integrate it at the end, you integrate that. So this is what is going to happen. Let's see, guys. Let's combine. And we just integrate. So that means our original question, the integral of, so you're going to have the integral of e to the exponent of x, the cos of x with respect to x is equal to what? So remember, how are we taking these? It's not going to change along this, across like this. Okay, let me just choose this one so that it can find like this. It's already integrated once you take it like this. This one, they ignore it. It's not going to work anyway. All right. So e to the exponent, but consider also the sign. So that means we're going to have plus, okay, that is going to just e to the exponent of x, the sign of x. Okay, let's move on to another one. Along the column, we still have this part of e, so it must multiply its cos. So we are taking e to the exponent of x along this way with the cos, all right? But also consider the sign. So meaning to say we're going to have minus, which is a plus. E to the exponent of x, the cos of x. All right. We are supposed to have e to the exponent of x going to this part, but we no longer have this because we stopped at this part. But where we stopped, it is not a 0 that we are having. So once this is not a 0, you have to integrate along that row. So meaning to say you're going to have plus, minus, which is minus the integral of e to the exponent of x cos x with respect to x. You stop that, then you integrate along that row. But now I want you to see. There we are done, guys. We are done. Look, this is e to the, remember we stopped where this is repeating, where there's a repetition. That repetition, it is because we want to take it this side, because that is our original question. So we're just going to take our repetition this side. Just like that. Transpose, because that's original question. We're not going to integrate. So do not worry to say, since this is integrate, I'm going to integrate. No, this one you're not going to integrate. So this is -1. Transpose it to the other side of our equation. That will be a +1. Already there's a 1. So 1 + 1, that will be 2. The integral of e to the exponent of x cos x with respect to x is equal to, remember, this has been transposed to the other side of the equation. We have transposed this to the other side of the equation. So we no longer have this part. We transposed this. So we are remaining with these two terms, this part and this part. All right. So that is e to the exponent of x, the sine of x plus e to the exponent of x, the cos of x. So that's it. So in this case, to determine our answer, what is affecting? Divide by 2 so that we obtain exactly the integral of what we are given there on our original question. A to the exponent of x, the cos of x dx is equal to. All right, so there we are just going to divide by 2, and also you can also factor out the e to the exponent of x. So it's going to be e to the exponent of x over 2 into the sine of x plus the cos of x plus the constant of integration. We are done. So that is the last stage, like the simplification. This one is just a simplification. Just a simplification that you're having. All right. So as we can see, we are going to need to work with more questions and more revisions. So I want you to see if for those who are having, or for those who are doing N6, the recent question that we had from our April, for those who wrote in April, or if you check, if you've checked the April question, you'll see that the I method was actually the easier part to work with than the normal integral that we are using. So there will come a time where you'll see that this is actually easier to work with. All right. So like I said, we just need 1 or 2 questions to consider. Let's say we are given the integral of x to the exponent of 3, and we've got 2 to the exponent of 5x with respect to x. Considering typical questions that we are given. How are we going to integrate such type of a question? This is actually our April. This is actually our April. How are we going to integrate that using this method? All right. There is x to the exponent of 3, which is part that we can choose to be our derivative. 2 to the exponent of 5x, you can choose this to be our integral. So you might wonder why choosing this to be integral, you can integrate this. Okay, let's consider, because if you choose this to be your derivative, remember it's going to be easier because you just differentiate, until you obtain what? Until you obtain a 0. It's a normal algebraic term. So we are going to have something like this. Sorry, guys. So we're going to have our derivative and also the integral. So in this case, we choose to have this derivative of a cos. The derivative of ax to the exponent of 3. So we've got x to the exponent of 3, the integral to be 2 to the exponent of 5x. All right, let me just explain about this part of our integral. Remember that the integral of a to the exponent of f of x with respect to x is equal to a to the exponent of f of x over the first derivative of f of x ln of a. That's our constant of integration. So if we can integrate this, so meaning to say if I'm given 2 to the exponent of 5x, to integrate this part, what's going to happen? A to the exponent, which is the original case as it is, 2 to the exponent of 5x over the first derivative of this, the derivative of 5x, which is 5. Then we've got the ln of a, which is the ln of 2. So we can integrate this. All right. On the other hand, we can differentiate this until we obtain as. Remember, this is our normal algebraic term. This type of it can be differentiated until you obtain a 0. All right, so let's differentiate this. Drop the exponent. That will be 3x squared. All right. Then on this part, we integrated. That is, we got 2 to the exponent of 5x, everything over 5 ln 2. All right, so this is it. And also you must consider the sign plus, minus, and so on. Plus, minus, and so on. Let's differentiate 3x squared. Drop the exponent times 2. This will be 6x subtract 1. Can we integrate this? Yes, we can integrate. So it's just like the previous case. Now we have to integrate this with respect to x. So the integral, remember, a to the exponent this. So it's going to be 2 to the exponent of 5x over what? We are supposed to have, just like the previous case, 5 ln 2. So we are going to have the 5 ln 2, but already there is this 5 ln 2, which is on our question now. So the 5 ln 2, just like x times x is x squared. So there's a product there. So it's just going to be 5 ln 2 squared. It's going to take it as a product like that. All right. So that means we are going to have 2 to the exponent of 5x. Everything over what? That is going to be 5 ln of 2 squared. So we're going to have 5 ln 2 squared. Everything being squared. So that is what we have there. So the sign, as usual, we're going to have a continuation here, plus, minus, a plus. All right. Let's see what we have. We do the same thing, the derivative of a 6x. So this is going to be a 6. Okay, that's we're going to have a minus here. Then we must integrate this. Again, so this is, do not worry about this, guys. It's just a repetition that is happening, just like what we had previously. This is now a ln 5 ln 2 squared like this. So you just integrate this part. Remember your integral, that part is going to remain as it is, 2 to the exponent of 5x. So you're supposed to divide by what? By 5 ln 2. But already there is this 5 ln 2 squared that we already have. So there's a product, same basis, we add the exponents. So that's 2 and 1, which is going to give us a 3. So meaning to say that will be 2 to the exponent of 5x over 2 ln 2 to the exponent of what? That's 5 ln 2 to the exponent of a 3. So you add 2 plus 1, which is a 3. All right, so this is what you're going to have here. 2 to the exponent of 5x, everything over 5 ln 2 to the exponent of a 3. So if you consider like this type of equation, you see that this is just a repetition that is happening. We started with 5 ln 2, that is now 5 ln 2 squared. So it's going to be 5 ln 2 to the exponent of 3, 5 to the exponent of 4, and so on. So if you're someone who is into this mathematical calculus, you'll see that it's just a repetition that is happening. So this part, I'm just increasing the powers and so on. So for us to understand that, that is to have more questions. The more questions you do, then you'll be able to realize that also that this is going to be a repetition throughout. All right, we are now, remember plus, minus, and so on. So now at plus, the derivative of a 6, the constant, so that will give us a 0. Meaning the integral of this, like I said, guys, is just going to be a repetition, 2 to the exponent of 5x as it is, but this is going to be 5 ln 2 to the exponent of what is going to increase. Like so, 1, 2, 3. So that will be to the exponent of a 4. In this case, we have obtained a 0 because we are dealing or we are working with a normal algebraic term. So there we are going to obtain a 0. That is where you are supposed to stop. So once you see this 0, you stop. And whenever you have got this 0 that we are seeing, there is no more any integral to be taken later on. There is no further integral to be taken on. But when this is not a 0 like other terms, we are going to integrate along the row. But in this case, there is no any integral to be taken. We are going to just take our answers as so these are the answers that we are seeing, but they are taken to be along, remember, along the across this part. We are going to take this across. So you're going to have this across. That is our answer. And considering the sign that we are given there. All right. So let me just try, guys. So we're going to have our question as it was. So that is the integral of x to the exponent of 3. Then we are given 2 to the exponent of 5x with respect to x. So this is equal to, let's take the first part and see. So that is the product of these two with a sign. So that's x to the exponent of 3, just going to multiply that 2 and so on. So it's x to the exponent of 3 times 2 to the exponent of 5x over what? So that was 5 ln 2. All right. So this is 5 ln 2. All right. So you're going to consider another part again. So you're going to consider along again. So this is, remember, taken across like this. I'm going to take this way. So that is going to be the product of these, considering the sign that is there. So you multiply negative times this 3x squared. So it's going to be times also, these are the just numerators. So it's negative 3. It's going to be negative 3x squared times 2 to the exponent of 5x over the part of the ln. So we saw that that is 5, the ln of 2 squared. Okay, so we're going to have that and so on. So let's move on to another part. That is the 6x here and this along. So you're going to take this. So it's just, and also the sign. So 6x is just going to multiply to the top. You multiply to the top there. So that is the plus 6x times 2 to the exponent of 5x, everything over what? That is 5 ln 2 to the exponent of 3. So that one, as we saw, the exponent of 3, it's increasing. Then we also consider this part, the 6 and this. Okay, so it's going to be across. Remember, taking across and considering the sign that is there. So it's negative times 6 times this 2 to the exponent. So that's a negative that you're going to have a negative 6. So that's a negative 6 times 2 to the exponent of 5x, everything over what? exponent that you're given. In this case, that will be 5 ln 2 to the exponent of 4. So that's 5 ln 2 everything to the exponent of 4. So as we can see, we are having what? A 0 there. We are having a 0. So there is no further integral. Even if you have to take the product of a 0 across like this, 0 times anything, the integral of the product of a 0 there will give us a 0. But if that was not going to be a 0, you are going to multiply the 2, then integrate as your final answer here. You integrate it, but the 0 times, guys, 0 times any number is what? It's a 0. So that means we are not going to have anything at the later stage. So that is our answer at the end. So I want us to consider the integration by parts. Yes, we are going to work with that question. Our April 2024 exam, going to work with that question so that we can also have an understanding with the normal integration by parts. But like I said, we need to talk about this, the concept of the integration by parts, but using the DI method. So it's just part where you need to choose the part that you can differentiate until you obtain a 0, provided that it's a normal algebraic term, differentiate and integrate on the other side until you obtain the original question that you are given. It's another part where you have to integrate until you see this part, you stop. So we must consider different types of questions also, so that we do understand this concept. So these are the typical questions that you might have on your integration by parts. So like I said, we are going to also consider this same question with our normal integration by parts. And you will see, guys, which part that is easier for you to continue with the normal integration by parts or to use the DI method, since it's part of our syllabus now. Okay, guys, this is what we had from Math Zone African Motives. Till we meet again.